How's it going, Soke?
Good morning, sir.
Good
How are
morning.
you?
I'm super tired. How are you doing?
I'm doing pretty good.
That's good. That's good.
It is good. Yes, exactly.
You should be doing good. Exactly. Yeah.
I think you fixed your table groups.
I fixed my what?
The table groups things where it makes you the voice chat.
I did fix it. I did fix it. I used a different bot for it.
All right.
Hello, Mr. Who.
Hello, Sean. How are you doing?
Doing good. How are you?
I'm doing all right.
It's good to hear.
All right. Oh, I'm so tired. Oh no. Zach, how are you doing?
I'm good, thank you.
Okay, so hello everyone. Happy Friday. Oh, I'm so tired. Ugh. Okay, so I'm super tired for the weekend. Join a table group in Discord. Otherwise, I'll put you in a Bruega room. This is going to be a little bit more important today because we're going to be starting a new project that's going to be involving groups. So I would highly recommend you find a group. We'll talk about groups later on, but just join Discord for now. And then in the Zoom chat, I want you to answer the following questions. So Usain Bolt. So his 100-meter world record, which he ran in Berlin, and I think it was 2009. I think he ran this in 2009. The 100-meter world record is 9.58 seconds. And so during the race, right, when the gun goes off, he is initially at rest, and then he'll finish the race sprinting at his full speed. So What I want you to do is I want you to find Usain Bolt's acceleration, and I want you to find his final velocity that he crosses the line with. So find his acceleration, his final velocity. His 100-meter time is 9.58 seconds, and he's initially at rest when the starting gun goes off. Note, there are a couple of ways of doing this as well. So, you can pick whatever way you want. And when I go over it on the board, I'll do it via both ways. So, for those of you just joining us, we have a problem on the board. Usain Bolt, his 100-meter world record, which he ran in the Berlin World Championships, I think. I think it was in Berlin, 2009, I think. He ran his 100-meter in 9.58 seconds. And so before the race, at the beginning of the race, right, he's initially at rest when the starting gun goes off. So I want you to find his acceleration and his final velocity. And let's see if we can get a few answers in the Zoom chat. We got one answer so far. Let's see if we can get some more. There are a couple of ways of doing this problem. And so you don't have to do it both ways, but I will show you both ways when I go over it. So let's take a few minutes to work on this, and let's get some answers in the Zoom chat when you're done. Usain Bolt, 100-meter world record is 9.58 seconds. He's initially at rest when the starting gun goes off. I want you to find his acceleration and his final velocity. And when you're ready, put your answers in the Zoom chat. One answer so far. Can we get a few more answers? Second answer, nice work. Let's take another 2 minutes or so, 2 or 3 minutes, see if we can get an answer for this. Usain Bolt's 100-meter world record is 9.58 seconds. He is initially at rest when the gun goes off. I want you to find acceleration and final velocity. We got a third answer. Can we get 2 more answers? 2 more, 2 more, 2 more. We got a 4th answer. Good work here. We got Sun, Tess, we got Sote. So as we're finishing up this problem, I'm just going to start doing this on the board. You can take some more time to finish it. So I'm going to show you both ways of how to do this. Method 1, so this is the way I thought of it. And this may actually be different than the way you thought of it. So the way I thought of it was, okay, we know that he starts off we know that he starts off with a initial velocity of 0. So because of this, because we know that he traveled 100 meters in 9.58 seconds, in a sense, we actually know his average velocity already. So we could potentially use a formula that looks at his average velocity to figure out how much time it takes. So the formula I'm going to use here is this one right here. X of t is x naught plus v0 times t Please plus v's. No. So I'm gonna use the formula for the average velocity, which is 1/2 times v naught plus vf times t. So this right here is his average velocity. So because of this, we already know his time. We know his initial velocity is 0, and we know that his initial position is 0. So if we make some changes, we know that his final position is 100 meters, and this is equal to 1/2 times his final velocity times his time. We do this out, 200 over 9.58 is equal to his final velocity, which means that his final velocity is about 20.9 meters per second. Okay, now so to find his acceleration, I'm going to use a different formula. I'm going to use this one, where we don't use time at all, or we just look at his displacement. So we can use this formula: v squared is equal to his initial velocity squared plus 2 times acceleration times his delta x. Delta x being his change in displacement. And velocity being his final velocity. Okay, so we know that his initial velocity is 0, so this is just 0. We know that his final velocity squared is 20.9 squared. And this is equal to 2 times acceleration times his delta x. Delta x is 100 meters because he traveled a total of 100 meters. And if we do this math out, we get that his acceleration is 2.18 meters per second squared. Okay, so this is the first method I thought of. The second method is probably the more straightforward method, the more traditional method, as I would call it. And so for this method, what we're doing is we're going to look at his overall position as a function of time. So his overall position as a function of time is x of t is equal to x naught plus his initial velocity times time plus 1/2 times the acceleration times time squared. Okay, so we know his initial velocity is 0. We know his initial position is 0. So all we get is his final position, 100 meters, is 1/2 times his acceleration times his time squared, which is 9.58 squared. If we do the math out here, we'll get that acceleration is 2.18 meters per second squared. And to figure out his final velocity, we're going to use his function for his velocity as a function of time. Velocity is his initial velocity plus his acceleration times his time. His initial velocity is once again 0, so his acceleration is 2.18 times his time, which is 9.58. This is the velocity. So his velocity ends up being 20.9 or so. 20.9 or 20.8, something like that. So those are the two ways that I thought of. There may even be a third one. I don't see, I'm sure there is. But those are the two methods I've thought of. Hopefully you got something similar to this. Does anyone have any questions about how I did this? Oh, no, you can't even see it on the board. Oh my God. That is, I forgot to switch the views. Hold on. That is a small issue on my part. There we go. Okay, so I'm so sorry. I realized I forgot to switch it. Yes, so I did two methods here. This is the average velocity method, where I use his average velocity, which is his initial velocity plus his final velocity divided by 2. His initial velocity is just 0, so I can just scratch that out. And so I get his 100 is equal to his final velocity divided by 2 times his time. And that gives me a final velocity of 20.9. And to find his final velocity, to find his acceleration, I use this formula right here. Vf squared is v naught squared plus 2 times acceleration times delta x. Delta x is a change in displacement, which is 100 meters. So 20.9 squared is final velocity squared is 2 times acceleration times 100 meters. So acceleration is 2.18 meters per second squared. So that's probably that's how I thought of it first. This method is probably the more straightforward traditional method, where you just model his Usain Bolt's position as a function of time. We know his initial position is 0. We know his initial velocity is 0. So we know that his final position 100 meters, is 1/2 times acceleration times his time squared. We do the math out, we get his acceleration is 2.18. And for his velocity, we get that his velocity is his initial velocity plus acceleration times time. And so we get that his final velocity is 20.9 as well. Does that make sense for you, Eagle? Does anyone want me to go over a certain part of that again?
I'm just wondering if we need to know both methods or if we understand one, is that good?
You don't need to know both methods as long as you know how to do a problem.
Okay.
So sometimes there may be a method that will be easier or harder, or sometimes a method won't work. So that's when you need to know how to use both methods. But in general, for a problem like this, right, as long as you can use one method, that's fine. Any other questions for me? Okay, so before we move on to the next thing, does anyone have any questions for me about the asteroid mission problems? I know I made a mistake on question 4 and question 5. I messed up on, so I made note of that in the announcements. But does anyone have any questions on any of those? Anyone want me to go over a certain thing?
We're not supposed to have turned them in, right?
Yeah, you don't need to turn them in. Okay, so if no one has any questions, we're going to move on to our next big and fun thing we're going to do. So the next thing we're going to do is we're going to start our next, well, this one will probably be smaller than the last one. And then our next project, which will involve cars, because who doesn't love cars? So what we're going to do here is we're going to take a look at this. Okay, so on Canvas, there is an assignment called Mario Cars. So you can open that up, and this is what I have right now. It's Mario Cars Part 1, I believe. So I'll just quickly give you an overview of what's going to happen. Okay, so in this project, what's going to happen is you're going to design the ultimate Mario car with the goal of being the fastest racer in Whoville. So this is going to be a group project with some individual elements. So I want you to pick groups of 3 or 4. You can have smaller groups, but you definitely cannot have bigger than a group of 4. So no groups of 5, no groups of 6, and you'll see why later on. So you will pick groups of 3 or 4. I want you to pick a new group than what you have. I will let you decide who you want to work with. And you can have some people that you already worked with, but I just want you to give you a chance to meet some new faces. So you know, once I finish explaining this, you can go pick groups of 3 or 4. I highly recommend that everyone get on Discord for this, so that way everyone is on the same platform. But if you're unable to, let me know, and I will instead set up a big breakout room for you instead. So and I'll reach out to you if you are not in a group yet. So that way everyone has a group. So to go with the task, the first thing you're going to do is you're going to customize your car. So in terms of customizing your car, the first thing I want you to do is I want you to draw your ultimate racing cars. This is very important. You will pick some components to customize your car, but I want you to draw your car in like a design. So when you include the later components, you don't actually need to show them in your design. You can just label them. I've had one group who decided they want to draw a pod racer. That's totally okay. It's up to you what you want to draw, as long as you draw something. And then your drawing will not make it more difficult to do the calculations later on. So it's okay to make it really poor drawing. So after you draw your car, or you can also do this sort of alongside while you're drawing it. what's going to happen is you're going to pick various components to choose from, with each one having a different statistic. So if you ever play Mario Kart or you've played any sort of like driving game or something, a lot of times you have different statistics for different cars and different parts and stuff. So the main statistics we're going to be working with here is going to be working with acceleration, velocity, braking, handling, and bad weather. So to give you just a brief summary, I'll get into a little bit more detail with these statistics later on, but acceleration is just basically how fast you can get to your maximum velocity. Velocity is just how fast your top velocity is. Braking is just how fast you can decelerate. Handling is how fast you can go around turns. And bad weather is how well your car can handle bad weather and bad conditions. And I'll talk a little bit more about the math behind some of this in a second. So there are going to be 4 components you can pick from. You can pick your tires, you can pick your engine, you can pick your car chassis, so car body, and you can pick your engine placement and your drivetrain as well. So in terms of tires, there are 5 different tires you can pick from. So you can pick your standard tire. So this is the car standard tires that come on pretty much all cars. So most cars that you're driving are going to have standard tires. You have your super soft tires. And these tires are used by Formula One cars and NASCAR cars. So they're very, 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 very fast. But because they're made for really nice conditions, so they don't handle very well in tough conditions. You have your off-road tires, which are sort of the opposite. They're really good in tough conditions. They're not so good in nice conditions, so they're a little bit slower. Sort of the opposite of super soft tires. You have aluminum wheels, which don't even have tires. And these are wheels that are used on cars with jet engines. So these are insanely fast. But because they are aluminum, you literally, they will struggle in any sort of bad conditions as well. So you get a lot of minuses with that. You have treads, which are sort of the ultimate off-road tires. They just will handle really bad weather and braking really well when they're really bad and everything else. So you have a bunch of options to choose from here. You also have 5 engines to choose from. You can use your standard Formula One engine, which is going to give you a good mix of everything. You have the Thrust SSE. So the fastest land vehicle of all time is the Thrust 2, which is literally a car with a jet engine, with a jet fighter engine. So it's very fast. By very fast, I mean it can go above 700 miles an hour. And it's very good acceleration. But because it is a jet engine, it can't handle very well. So you'll see if you want to do that. Then you have your standard Tesla engines. So Tesla engines, because they're electric motors, they have instantaneous torque. We'll see what that means later on. But basically, they just mean that they have very fast acceleration. And so you're going to have a car with good acceleration, good velocity, and not so good handling. You have your W16 engine, and this is the engine that goes into like a Bugatti. So they have very good velocity. They're very, very, very fast. And they're not so good in acceleration and handling, but they're pretty good in both. And then lastly, you have a V4 engine. These are the engines that go in rally cars. And so they're very good with acceleration. They handle very well. They don't have as much horsepower as the other types of engines. And then you have 5 different chassis here, 5 different car types. You're gonna have your Toyota AE86. So if you ever watch the Initial D, which is an anime, it features this one Toyota car, which everyone underestimates. So because it's a standard Toyota Corolla, it doesn't have very fast speed. It doesn't have very good acceleration, but it handles pretty well. Then you have your standard Lambo, which is very fast with minuses in your handling and bad weather. You have your muscle car, which is very balanced overall. You have your F1 car, which is very fast with pretty good handling as well, but not so good in bad weather. And then you have a Cybertruck, which I included because Cybertrucks are super sick, and you can fight me if you disagree. And Cybertrucks are pretty good in tough conditions. And yeah. Last but not least, this is probably the most complicated one, but you don't really need to know the details of it. There are 5 different engine layouts and drivetrain layouts. I'll sort of go into what each one means. So the FF means front engine front wheel drive, which means that your front wheels are the one that's going to be powering your car, and your engine is also located in the front of your car. This is the engine layout that will pretty much every single car that you uses. So pretty much all normal cars use this layout. So they're pretty good at handling, and but they're not as good in terms of your speed. Your FR, these are sort of the engine layouts that sort of go into like cars that like to drift a lot. So these are like front engine, rear wheel drive. So your engine's located in the front, and your rear wheel drives. Your rear wheels are going to be powering your car. So they get better at speed and acceleration. They don't handle as well in bad weather. You have your MR. This is your mid-engine rear wheel drive. So this is what you see in a lot of really fast cars. So like your Bugattis, your Lambos, your Formula One cars, they all have mid-engine rear wheel drives. So they're very fast, very good acceleration. You have a rear wheel drive, which is what you see on a rear engine rear wheel drive. And this is what you see on Porsches a lot. They have really good speed, really good acceleration. They're pretty much bad in everything else. And then you have a four-wheel drive, which is very good in tough conditions. And four-wheel drives are usually what you see in like Jeeps and trucks and stuff, with very good braking and bad weather penalties. So what you're gonna do is you're gonna pick one of each one, and then you're gonna put this in the table down here. So the questions that, there are a bunch of questions I want you to answer here. And this is what each person's gonna be submitting. You can work together on this. You can even have the same one, but it's fine. So you're gonna create a name of your car. You're gonna put the list near all your group members here. And then I want you to fill the bottom tables with your chosen components. So you're gonna put your tires here. You're gonna put your engine here. You're gonna put your chassis here. You're gonna put your drivetrain here. And then I want you to do is I want you to fill in the bottom table with your final point values for each. You're gonna fill in your final, I don't know what happened here. You're gonna put your final point values for your acceleration, your velocity, your handling, your braking, and your bad weather. So this is your total number of points you have. So this is in an average. So in this example, I have a total of 20 points in acceleration. You're gonna have 10 points in velocity, -5 in handling, whatever your total was, and you're just gonna put this in here. So then this next table part is the part where you need to do some calculation. I don't know what happened here. This next table here is you're gonna do some calculations. So you're gonna try to calculate how your acceleration, what your velocity is, what your handling is, and what your braking is, based on your statistics. So to show you how you calculate this, in your car, all cars start with a base acceleration of 5 meters per second squared. Every additional point you have in your car adds 1 meter per second squared to the acceleration. So let's say you have a car with,
We can't see your screen.
oh yeah. Hold on. What? Oh God, I'm really like super tired today. Oh my God. Okay, so here we go. Okay, so I'm on the board right now. So if you have a car with 20 points in acceleration, you're going to start off with initial acceleration of 5, and then you're going to add in 20. Your final acceleration is going to be 25 meters per second squared. So that's for your acceleration. For your velocity, each car starts off with initial, let's say you have a 20 here. Each car starts off with initial velocity of 40. Each point you add adds 4 meters per second to your top velocity. So what you might have is 10 times 4. This is number of points. This is 4 meters per second per each point. So you're going to have a total of 80 meters per second for your final velocity. Your braking is going to be pretty much the same thing as your acceleration, which is negative. Your handling, each point just adds 4 meters per second to the top speed of that you can go around turns. There is a limit. Each turn of a race course is going to have a limit to how fast you can go. You'll see later on, but just for now, just calculate how much faster your car can go around turns. And each negative point just subtracts 4 meters per second. Then you have your last one, you have bad weather. So bad weather, what's going to happen is your race course is going to have different penalties for bad weather. So your rain might slow down your overall speed or so. The point of the bad weather is just reducing these penalties. So if you have, let's say, if you have 10 points in bad weather, for example, your car is going to have a 30% reduction in bad weather. So you're going to answer these questions as a group in your Google Doc. And then what else? Okay, then you're going to answer 2 more questions at the very end. Make sure I know what's going on here. I need to change this up in this table. Okay, so at the very end, you're going to explain your car design as a whole. And so I just want you to explain which components you picked and why. What were you considering in your aesthetics, your performance, your speed, your acceleration? And I also want you to include every design choice you thought about, which might be stuff like, is it electric? Does it run on biofuel? Does it run on gas, etc.? And then I want you to decide which statistics you decided to emphasize and which ones you didn't care about in terms of, do you care about velocity, do you care about handling? And I just want you to share your reasoning about that. So does anyone have any questions about the project? Okay, if you don't have any questions, I'm gonna let you find your own groups in Discord. And when you're ready, when you finish your groups, just start working on your design, and then I'll check and see how everyone's doing. So yeah, get started. So I need 2 volunteers to join table 13 because we have 1 person by himself and I want groups of 3 or 4. So can we get 2 people to move to table 13, please? Would be much appreciated.
Mr. Hu, if we're done, can we submit?
If you're done, you can submit it, but have you finished your drawing too?
Does our drawing have to be on paper, or can we just do it in Google Drawings?
You can do it in Google Drawings.
Okay. And how should the how should the drawing look like? Just a basic drawing? Or
Just draw what you want your car to look like.
Okay. in the drawing, sir, do we actually have to say like what each part of the drawing is? Mr. Hu?
So we have a minute left in class, so I'm just going to wrap up here. So your only homework for the weekend is to just finish your design and submit that. I just want each person to submit their own copy. It's okay if it's the same. It's just I just want each person to submit it. And then make sure your car actually has a picture design. So don't just put in all those numbers and stuff. Like I do want to see a picture of it. It does not have to be accurate. It doesn't actually have to reflect the design choices you made. I just want to see some car design that you picked. So that's your only homework for the weekend. Otherwise, if you don't have any questions, you're free to go, and I will see you all on Tuesday. Bye-bye, everyone.
Thank you.
Thank you.
Thank you. Have a nice weekend.
You too.
Thank you.
Bye-bye. Bye-bye.
Can we assume that because our motor is made by Elon Musk, it is mind controlled?
Yes, you can. You can.
I don't know if
Nice
that's
one,
gonna
sir.
change. I don't know if that's going to change the outcome of any race, but yes, you can.
A nice one.
Okay, you too. Oh, yeah, yeah.